So this question can be solved in two different ways. One would be to solve A and B separately. When I say A and B, I mean two cars, car A and car B, separately. Or then by analyzing the relative motion and combining the motion of A and B separately, by combining the motion of A and B into one car, AB. Okay. So first we'll go through the separate approach where we'll see the solution by considering motion of A and motion of B separately and then finding out the solution. And then we'll see how to solve the same question using relative motion. So in this approach, where we consider the motion of these two cars separately, what we have is car A and car B, which are approaching towards each other, right? With deceleration 2 meter per second, and therefore we assume acceleration of A as minus 2 meter per second square and acceleration of B as minus 2 meter per second square, and the relative separation between them as 300 meters. Now let's see the motion of A alone. So when we have motion of A alone, we have car A coming with a speed of 20 meter per second, decelerating at a pace minus 2 meter per second square, right? And finally this car comes to rest. So initial velocity is 20, acceleration is minus 2, final velocity is 0. By equations of motion we have v square is equal to 0 square is equal to u square 20 square plus 2as. A is minus 2, and therefore what we get is SA, which is distance traveled by A when it comes to rest, as 100 meters. 100 meters. Okay. So let us say, we'll come back to that part later. So now we'll see the case of motion of car B alone. So when B is approaching, right, B is also approaching in the same direction. Acceleration of B is minus 2. Final velocity is 0. By equations of motion, v square is equal to u square plus 2as. Final velocity is 0. So what we have is 0 is equal to minus 20 square plus 2 into minus 2 into sp. Now, what we need to understand here is a common mistake that most of us make is that we take this ub as plus 20. No. Why is it minus 20? Because we assume the direction of A to be positive, and therefore we took it as positive 20, which means it is opposite direction in which car B is moving. Therefore the velocity has to be assigned minus 20. Okay. So what we get is minus 20 square is 400. Transpose what you get is minus 400. 2 into minus 2 is minus 4, and therefore we get that SB is equal to 100, which means distance traveled by B before it comes to rest is equal to 100 meters. Now let us combine these two. And put it in one single chart. So A was traveling with 20 meter per second, right? It reached this position R where it came to rest. So I'll just mark that. So it came to rest here. B was traveling with 20 meter per second, and when it came to this position S, what has happened? B is at rest here. So B is at rest here. So now for better clarity, let me just erase out these two. Now we don't need the initial positions, right? So this is the final position. This is the final setup. Now the initial distance between these two, which marks this distance, PQ, is, right? The initial distance PQ is equal to 300. Excuse me. Now geometrically, PQ can be written as PR, right, plus RS plus SQ, right? Or maybe let me just write over here. So PQ is equal to 300 can be expanded as PR plus RS plus SQ, which is equal to 300, right? Now, what is PR? PR is the distance traveled by car A before coming to rest. What is SQ? What is SQ? SQ is the distance traveled by B before coming to rest. And what is RS? RS is the final separation between them after they have come to rest. So SA is 100, PR is SA, which is equal to 100, SQ is SB, which is equal to 100. Therefore, what we get is 100 plus RS is equal to 100, and therefore RS is equal to 300 minus 200, which is equal to 100, which means the final separation, right? The final separation is equal to 100 meters. Therefore, the correct option here would be option C. Now, what we'll do is, in the next half, we will discuss the same solution, but this time using relative motion.